Maybe.
Oh, okay. Hey, everybody. Welcome to Unit 3. Before we hop into some Java stuff, I'm going to turn the mic over to Ryan, who's going to talk to you about some logistical things.
Cool. Hi. Okay, so we're heading into Unit 3, which is the Java skill track for this class. And so I'm going to let Doug talk like a little bit more about why Java is good. But the long and short of that from the launch code perspective is Java makes up the vast majority of job opportunities in the St. Louis metro region. If you're looking at desktop development or web development, you're probably looking at like 60%, if not more, Java coverage for those markets. And so that's why we like to teach Java more often than we teach everything else. And so because LC101 is all about getting you job ready, Java is kind of what we choose to go with. But what I'm going to talk about today is what's coming up in terms of logistically for the rest of the class for graduation and what comes after LC101. And there are like a couple of paths that you can go and choose, though there is one path specifically that we recommend. Okay, so basically like these 4 things are the things you got left to do. So it's that easy, really. Yeah, it's just check them off as you go. But in all seriousness, like we're 2 months out basically from the end of the class here, and here's what we have left to go through. Finish assignments. There are a few assignments in the Unit 3 skill track. All of that stuff is already published to the Canvas course. So if you haven't been able to find it on Canvas, you need to actually go to the main dashboard page of Canvas to get access to the Unit 3 stuff. It's in a separate Canvas course. If you can't find it, ask somebody else to help you. But you need to finish all those assignments. They're all published. After that qualifies you to graduate. Talk about graduation in a minute. The class doesn't end with you building a project. So we don't actually cover like building your own project on your own. And if we were writing LC101 today, we probably would do that in class, but we aren't writing LC101 today. And so as the class was originally designed and scheduled, and I'll talk about this a little bit more in a minute, it ended people up with the skills to do a project, and then we basically sent them off on their own and said, okay, go build a project now. And predictably, that didn't go very well. So now we offer a little bit more structure for that process, and we'll talk a little bit about that later. And then after you've finished building a project, you can start your job search, whether that's through launch code or not through launch code or both, and you'll be ready to set up to go for that. And I'll talk a little bit about the structure that we provide for that job search if you choose to go through launch code, and also just like general best practices if you're going to do that job search on your own. This shouldn't come as a surprise, but the past requirements for Unit 3 of LC101 are exactly the same as all the other units of LC101. You have to have a passing grade for every assignment to pass the unit and therefore pass the course. There is a completion cutoff date for receiving a certificate at graduation. That isn't a cutoff date for receiving a certificate altogether, but to have it at graduation, we do have a print date that we send off to get those certificates printed, and so like it's really a practical issue. So if you're finished by July 8th, that's when I'm going to send out the print order for those certificates. If you finish after July 8th, like it says, you can take up to 2 months after the end of class to finish. You can still receive a certificate. You just have to come pick it up at the Launch Code Mentor Center. So what does this mean in terms of like the rest of Unit 3? It means that you need to finish the remaining projects, or the remaining assignments, right? So like still during Unit 3, it's going to be tempting to like really start thinking about, oh, what am I doing after this? You know, what are my next steps? Because we recommend that if you're building a project, you build it using your skill track language, like I said 60% plus of the market in St. Louis is Java. So it means that even though you probably love Python, like all LC101 students before you love Python, it is not kind of the language du jour for what we recommend for building your project. And so you really need to focus in Unit 3 on getting Java underneath your belt in addition to everything that we've taught you so far, and really focus on getting these assignments completed on track. Once you've done that, you can begin to ideate your capstone project, by which I mean start to think about the kind of things that you would build using the tools that we've taught you to use, right? So using basic, what we call CRUD functionality, create, read, update, and delete. What kind of web project would you build using those features, basically? What thing would you build that's like blogs or like the assignments that we're going to do in Unit 3? Be thinking about the problems that you want to solve, but don't get like too deep into like ideating how exactly you're going to build your project. There'll be time for that down the line. Right now, you need to focus on learning stuff still. So we're gonna graduate you at this time, at this place, July 11th, 6 p.m. to 8 p.m. It's gonna be here. There will be a link that goes out for people to like reserve tickets for those things. Someone asked me on Slack the other day what we're gonna charge for the tickets. The answer is they're free. We gave you this entire free class, and then we're going to charge you $200 to show up to graduation. Aha. No, it's free. It's free. It's free for you. It's free for anybody that you want to invite to come see you graduate. And you're encouraged to do so within reason. Like, you know, some of you will invite like 1 or 2 people. Others of you will invite like 10 people. Probably try to like stay in that range, give or take. But this is, I believe, a Thursday that we've scheduled this for. So it'll be July 11th, 6 to 8 p.m. We'll have some speakers here that'll talk about launch code and the organization, and talk about programming and that sort of thing. And then we will have a chance for you guys to share your stories if you want in front of the gathered assembly of graduates and family members. So there'll be an open mic session that if you want to come up and share your story and talk a little bit about launch code and LC101 and the skills that you've gained, there's an opportunity for that. And then we will have a procession where you'll receive your certificate. There will be also, like, all this stuff's going to be in the event invitation, but there will be like some drinks and like some light appetizers and stuff like that. So like, don't get like too lit when you show up, because there will also probably be employer partners here. But you know, this is a celebration for you, so have a good time. And then I already said this stuff down below. If you don't finish, like we get to the end of the class that you're not done yet, please still do come to graduation. Like, we want you've spent all this time, all this effort. Please do come to graduation, regardless of whether you're still working on like the last 2 assignments or not. Right? We want you to be here with us and celebrate. Like I said, you have 2 months after the end of the class to complete those assignments. So please show up. Please celebrate with the rest of the students. If you don't receive a certificate at graduation, you just have to show up to the Mentor Center. You can show up anytime during regular business hours or during a time when we have a class to pick that up, and it'll be here for you. Okay, so I have 2 other things I want to talk about, and one is the Capstone Project in general, kind of the reasoning why we asked for it, and what Capstone projects kind of look like to a certain degree. And then I want to talk about the job search process that results from that, which can either go through our Liftoff program or through searching on your own. So for the Capstone Project, a lot of times students ask us, like, just why? Like, why we have to do this? Like, why doesn't the course, doesn't the course teach us everything we need to know? And the answer is yes, the course does teach you all the skills that you need to know. But if you remember back, like way back to the first day of class, when I said that launch code is not a credentialing institution. That's still true. The certificate that you're going to receive at the end of the class only means as much as launch code means, right? Like, it's still an important thing. Like, I got 3 different degrees, right? Before I took LC101 back in the day. And my LC101 certificate is still one of the things that I'm most proud of. But it still only matters as much as like we matter. So what you get out of this opportunity through the class, those skills are important, and we can back you up on those things when we send you out to places. But you still need something to show, right? You can't just take in blogs to a company and be like, I built this, because like, one, like, no, you didn't really, right? Like, yes, but no. And it's building, ideating, planning out, building your own project is a separate skill set entirely to the stuff that we've been teaching you. Like, you'll use all the tools that we taught you to do it, but it's such a different process, such a different experience, and it is something that employers expect to see is original, creative work that you've come up with and executed on your own. And so this goes in place for things like traditional CS degrees. This kind of replaces that, is that you've done this already, so they should take you. It's also like, I don't know, it's just fun to build things. Like, I hope you think that at this point in the class, because otherwise we may have wasted your time. It is fun to build things. It's fun to solve the type of problems that you'll solve when you're building your capstone project, and you're going to learn so much more as you're building it. Yeah, so it's important, more or less. So we use the Capstone Project as a way to vet our apprenticeship candidates. So when people come to us for an apprenticeship, and they haven't gone through LC101 programs, they've either learned on their own, or they've gotten a CS degree, or they've taken another boot camp aside from LC101. What we use to determine whether or not they're job ready is the project work that they bring us. And so because of that, we set the same expectation for our own students, because we hold that true for people that we don't educate. We also want to hold that true of people that we do educate. And so everyone that goes on into the apprenticeship placement program is required to have a capstone project. It's a project that demonstrates your skill and knowledge. And for most students, most of you, it will be a web app of some sort. That's what we taught you how to create. At least theoretically. So that is probably where you will go. Some of you may choose to go completely off-piste and build like a mobile app or do something with hardware or something like that. But the vast majority of you will probably have a web app. A web app will have something like 3 to 5 features. And you may be looking at that and being like, what's 3 to 5 features? What does that even mean? The answer is we don't really know, to be honest. It's kind of more of a gut feeling thing for us. But what I will say is that something like blogs, if you had created it on your own, it has certain CRUD functionality, even though it's really only actually creating and reading and not really updating and deleting unless you implemented extra stuff on top of it. But it has the user is able to sign in, create an account, make some objects. Other users are able to see those objects that are owned by users that aren't themselves. And there's, the ability to click through and see individual pages. We would say that blogs, as written, probably constitutes 2 to 3 features for the purposes of how we look at capstone projects. And if you want to see more capstone projects, you can see examples on the Liftoff curriculum site, which I linked here, which is not helpful because it's on the screen and you can't click it there. But I will send out this presentation as a PDF, so you'll be able to see and click through there. But it's also on the education webpage, so if you go to education.launchcode.org and click on Liftoff, you can go in there and you can see they have some examples of projects that people have built in the past Liftoff students. It also has examples of projects that LaunchCode staff have built underneath the same like constraints of Liftoff. So it's a good place to go and check out and see what capstone projects look like and as determined by LaunchCode. Also, like you could ask your TA to see theirs. Whether or not they want to show it to you is a different story, because I wouldn't show people my capstone project now. But you could absolutely ask to see your TA's capstone project. Maybe they'll have it running, ? It might have been a minute since they last opened it up and ran it, so you might have to give them some time to clone the repo and figure out how it works again. I do just want to emphasize that traditionally, we did ask students to do this on their own after LC101. And we had probably, when we were doing that as an organization, we had probably like maybe 1 in 5, 1 in 4 students come back who had graduated from LC101 with a project, which is obviously not a good return rate, right? It turns out, something that we underestimated the complexity of and the difficulty of in the past, which is why we built Liftoff, which is what I'm going to talk about right now. So how do you build a capstone project? Well, you can do it on your own. Like I said, people have done it in the past. You know, hundreds of launch coders have finished a project after finishing LC101 on their own with no additional help. That's how I did it. I didn't have Liftoff. It was a real mess. It is a viable option if you're a driven worker who's already ahead of the class or who wants to get a head start. If you're going to do this, I still recommend, if you want to be an intrepid individual who attempts to complete their capstone project without going through the Liftoff course, I would still say, please utilize the curriculum on the Liftoff education webpage to help guide you. It will save you so much heartache, so many difficult days of just banging your head against a problem that, had you structured your project differently, could have been avoided. So if you want to do that, if you're the kind of person who's already like 2 or 3 assignments into the Java skill track, I know there are at least a few of you out there. If you want to do that, I encourage you to do that and get a head start working on a project. If you do want to build a project through Liftoff, congratulations, that's the right choice. And Liftoff is, it's an organized introduction to things like project ideation, design, and implementation. It allows you to get additional support from not just other students, so not just being around in a group of students, much like you're in a TA group now. Being able to bounce ideas off other people and hear other people's problems that they've encountered, super helpful versus trying to fly solo. And also we have mentors who guide groups of somewhere between like 6 to 8 students. So you'll have like one-on-one time with a mentor as well to help guide your creation of these things. And also something that we started doing, I think it was the first time we did it was probably right at the end of last year, is doing group projects during Liftoff. So this is probably something we're going to continue to do with this upcoming Liftoff, is give you the opportunity to work in a development group of 4 to 5 students and work on a more advanced project together. So if that's something that maybe you're interested, like think about that as you're going through the rest of LC101. Be prepared for that eventuality. We'll send out a survey before Liftoff being like, hey, who's interested in doing a group project? That has like its own pros and cons versus doing an independent project. I think there are some people who would see like, oh, I get put into a group with other people and we get to work together, and like when I don't know how to do something, somebody's gonna be there to like help back me up on that. And like, that's great and that's true, but it's also like somebody's gonna be there to like yell at you because you didn't do your thing that you were supposed to do, or they disagree with the way you wrote your code, or you'll have to figure out merge conflicts in your Git repo. So there are pros and cons. And just to be completely transparent, we've had like group projects that have done like really well, and everyone in that group project learned so much, and they all went on to get placed super quickly in new jobs. And we've also had group projects that have just crashed and burned just spectacularly within the first couple of weeks. Just everybody was like, no, we should do our own projects. So just in full transparency, it is something that we're figuring out as we go along. Yeah.
So in other words, we can do one all on our own, or do one within a group, not one of each.
Not well. I mean, you're welcome to do whatever you want, but yeah. So yes, the idea is that you can do an independent project, or you can take the opportunity to do a group project. But either way, you'll be with other students who have the same mentor, regardless of whether you're doing an independent project or a group project. It's just in a group project, you're all building a thing together, and on your own, you're all building separate things in proximity to each other. So Liftoff, from a high level, is an 8-week course. It is meant to help walk you through the process of building a Capstone project, but it also gives other skills, like we teach a little bit more in depth about live coding and whiteboarding, which is an interview process that's commonly used in the tech industry, where basically you're given a problem on a dry erase board and you have to solve it in front of your interviewer. It's extremely stressful and absolutely terrifying in some cases. And if you talk to any developer who's been working professionally, they'll have both really positive stories about times they really knocked those interviews out of the park, and they'll also have like horror stories about a time that they were asked to do it in a language that they didn't even know. So we used to not give any guidance on this to students, and now we give a lot of guidance on this to students, because it is an important part of getting hired, for better or worse. It is an important part of getting hired as a developer. So we teach about this in Liftoff. We also teach about something called Agile, which is it's a method of creating products, kind of. If you have questions about Agile, ask Jake Wells, who's a TA. He's over there. That dude is a Scrum Master, so he can tell you all about Agile. But it's really popular in tech right now, and so we teach that in Liftoff as well. We also do things like interview practice, resume building, teaching you how to build a LinkedIn profile effectively, and just other general job readiness skills. So it's also I can't understate this enough, or overstate this enough. It is a community that provides support as you build your project. As someone who built my project entirely by myself, I really, really wish I had people to talk to as I was building my project. It was a very lonely 4 months. So if I had Liftoff and been around people and been able to build it in 2 months, I definitely would have taken that option. So here's kind of the catch, is that we do Liftoff on Tuesdays. I'm telling you this now, way in advance of Liftoff starting, so that you can plan accordingly. I know that sucks, the time change from Monday, Thursday to Tuesdays. It's really a practical reason. It's just we don't have space. If we have to run another LC101 after the end of this one, the Mentor Center is taken up on Mondays and Thursdays. So Tuesdays is unfortunately the remaining day that we can use the Mentor Center. So it is Tuesday evenings from 6 to 9 p.m. We're going to start it on July 16th, which is the week after graduation, and it runs through September 10th. And it's going to be here. Does anybody have any questions about that? Is that unclear? Yeah.
My question is what if we can't for schedule work or something, right? Would do that? Can we do the following Liftoff?
It is almost always on Tuesdays. So yeah, if you need more time to figure it out, to make that shift or something, we could roll you into a following Liftoff. Though I will say the next Liftoff probably won't run until, sorry, I'm trying to visualize a calendar in my head. It probably will not run until September or October. So it's gonna be a hot minute. So definitely try to make this work to the best of your ability. It really is best if you go directly into Liftoff after LC101. We've had cases before where people like don't do that, and they're like, oh, I really need a break, LC101 really drained me out. And then they come back 3 months later and they're like, how do I write a for loop? And so like it's really hard at that point for us to help you. But we're we can talk about individual cases like that, definitely, on a case-by-case basis. Otherwise, try to shift what you can. Be here on Tuesdays if possible. If not, and like you're like still definitely want to do this, like I said, the curriculum is there, and like it is a lonely process, but it is achievable to do a project on your own, and that's probably the better option than waiting, to be honest. Does anybody else have anything about this? This is also Liftoff leads to this stuff, which is job placement. So these are the two possible ways that you can enter the Launch Code Apprenticeship program. And if you're not interested in entering the Launch Code Apprenticeship program, you can get out. Listen, I need those metrics. No, but in all seriousness, you can just like turn off your listening device for a minute. So to get into the Launch Code Apprenticeship program, you either have to complete a project and apply through the Launch Code website, where you'll need to fill out our application and then come in an interview with one of the people that works underneath me, and then we'll have you jump through all the hoops and stuff, which is what we do for people who don't go through our classes. We do this process. So basically, you just would apply like a regular apprenticeship candidate who learned outside of Launch Code. Or you can complete the Liftoff program and fill out the survey at the end of the course is the other option. Either way will get you in the apprenticeship program. If you go through Liftoff, it obviously lets us see things along the way, and we don't have to do things like bring you in for an interview and make you do like more live coding and have you like do online tests and stuff like that. If you do Liftoff, all that stuff's taken care of for you. So here's how the apprenticeship program works. I talked about this way early on in the class, so I'm going to talk about it again now because it's been a second. And so it's on a high level, it's a pretty simple process, right? You either go through the regular Launch Code Apprenticeship interview process, or you go through Liftoff. But either way, regardless of which of those options you go through, what we do is we fill out a profile for you in our system, our internal system, and we mark you as job ready. And that puts you into our pool of candidates that we pull from. Once you're in the candidate pool, what happens is job requests come into Launch Code through companies, and our company relations team, which you'll have a chance to meet at some point, either at the end of this class or in Liftoff, you'll have a chance to talk to those folks. But they're the people that source the job requests from company partners, and they go into our system and they basically do something like, hey, who knows Java, right? And then our system pops up like everybody in a big old list, right? It'll be all of you. And our company relations team will browse through those people and be like, okay, who's gone on an interview recently? Who hasn't? Let's pick out people and try to make sure everybody gets equal coverage and things like that. And they basically contact you and say, hey, we'd like to send your resume, your profile over to this company. Are you interested? If you say yes, they do send your resume or your profile over to that company, and the company chooses whether or not they want to bring you in on an interview. When you go in on that interview, you still have to land the interview. You still have to do a good job, right? We're kind of providing this middleman service of saying hey, we know all these candidates are good and companies trust us, and say, okay, send us candidates that are good. So when we send you on an interview, we appreciate it if you're good. Would be nice for us in a lot of ways. So we ask that, when you go on an interview, you complete your interview, you really blow them away during your interview, and they have a couple of options at that point. They can choose to bring you on for an apprenticeship, An apprenticeship is a full-time paid contractor position. The way it works is you work at the company 40 hours a week for a time period of 3 months to 9 months, somewhere in there. It varies by company, and it's kind of, we're pushing for like 3 to 6, but sometimes companies want to do 9. The company team will talk about that later. But you do that full-time position there with the expectation that if you do well in that kind of extended apprenticeship process, you will be offered a salary and converted into a full salary developer at that company. Our success rate is about 4 out of 5. It has been for the last couple of years or so. That is 4 out of 5 people who start an apprenticeship get converted at the end of the apprenticeship. And so it really is like the cases where people don't get converted are like pretty egregious cases most of the time, where like someone just like either did a really bad job or like the company's like, well, actually, we don't exist anymore. It does happen. We try harder now than ever to avoid that. But it has been the case where companies have like, shuttered an entire arm of their corporation while people were working at an apprenticeship, or have like completely shut their doors during that time. But we try to avoid it when possible. So that is kind of the process. If they don't choose to bring you on for an apprenticeship, you just go back into the pool and we pull you out for the next opportunity, to go send you out again. The actual like apprenticeship process, we'll continue to like talk about that going forward throughout Liftoff and after Liftoff. But the idea is that you start making $15 an hour. We're pushing to up that to $20 an hour, but it's still kind of like a fight with companies to get them there. So right now we're still telling people 15, but by the time you graduate, it may be 20. And then along that apprenticeship process, we do pay bumps at 3 months, 6 months, 9 months if necessary. So by the end, you could be making like $25, $30 an hour at the apprenticeship while you're still working on it. That also includes like 99% of our apprenticeships we do also allows the apprentice access to Launch Code's healthcare plan, the same healthcare plan that I use. It's fine. It's not great, but it's okay. We used to not have that option available, but as we've tried to change the way we do apprenticeships, we've tried to always make better changes that result in a higher quality opportunity for the apprentice. So we're constantly pushing for higher wages. We're constantly pushing for things like health insurance and things like that. So we're trying to do those fights. So what can you be doing during that process, right? Because it's not like you finish LC101, you go on to Liftoff, you build your project, and then like you're done, right? And you're just waiting for the right interview to fall. Like if you do that, you're gonna be waiting a while. You should really take this to heart that during the job search process, you should continue to be building and learning. You should be, pick up a book, watch a YouTube video, add on to your project, build a new project, learn a new skill set, practice your programming skills, do some programming practice questions, right, on HackerRank or somewhere like that. The people that do that find jobs quickest, which is like not surprising, right? But sometimes people have to be told that. So I'm telling you that now, is that the work that you put into your job search process will get repaid to you in terms of how quickly we were able to find you a position. Also, that includes things that aren't programming related, like practicing your interview skills. If you know you're a bad interviewer, I'm a bad interviewer, right? I'm surprised I got this job, to be honest. But if you know that you're a bad interviewer, like practice those things. Don't just sit around and like hope that it works out. You know, we're going to provide tools for that during Liftoff. You can find tools for that online. You know, bug your family members, bug your loved ones, bug your friends to run you through mock interviews. Hone your resume, get out there and network, go to meetups, you know, show up to employer events, go to things like Venture Cafe over at the CIC, things like that. We'll provide links to all those things at some point. So if you aren't doing those things already, like maybe consider start doing them. And also, like, it's gonna suck, right? Finding a job is terrible. The job search process, the interview process. I mean, I know I don't have to tell you this, but it is going to be it's going to be a rough process. And so we're going to constantly at LaunchCode be working here to help you find those opportunities and help you find the right one, help make sure that it lands for you and help make sure that you convert for those things. But just stay positive. Take every L as a chance to learn something. And we're going to be here to help you along in that path, right? So some of you will find a job immediately. That's just how it works. Some of you, if you're like me, it will take months. So don't be like me. But we're gonna constantly be putting effort in to get everybody who wants to be placed through LaunchCode placed into a job. That's our goal. That's why we exist. We don't just do the easiest people and then be like, okay, awesome, job done. We're gonna work as hard as possible to get everybody into a position. So, all right, I'm done. What, if any, questions do you have about all this stuff? Nothing. Perfect job. Awesome. Yeah.
Is it possible to kind of take the middle path, to get out ahead, start working on a project,
Sure.
and roll into Liftoffs?
Yeah. So the question was whether or not you can take the middle path, air quotes, and get ahead. Start working on the project before the end of class, but still choose to enroll in Liftoff. That's fine. I would probably even if somebody finished a project and wanted to do Liftoff, I would probably let them do Liftoff, just because it doesn't hurt. It can only help you. So, anybody else? Yeah.
What's the official last day of this project?
What a great question.
I might know this one. Hang on, let me look
What a
at the calendar.
fantastic question. If anybody has Canvas open right now, I'm hearing June 27th.
That sounds right.
Sorry, there are a lot of classes. I'm very bad at knowing when they end. Yeah, June 27th, then you have a couple weeks in there to finish up all the assignments before graduation. All right, last chance, and then I'm gonna hermit myself away in my office. No? Okay. I'm also always available. I know I don't say this enough, but I'm here every Monday. I don't know if you know this. I'm here in the building every Monday during class. I'm back there. If you need something, I'm back there. So it says staff only, but feel free to come in and bug me. Cool. All right. Bye, guys.
All right.
Sorry, 1 second. You don't have to sign up for Liftoff. There will be a spot for you to just check it. So I'll make sure everybody knows when that comes up. So it'll be near the end of class, but there's not somewhere you need to apply or anything. You'll know. It'll be okay. I've got you.
Oh, definitely. Okay, you guys are stuck with me now. Probably. Ryan is still walking, so I'm going to take that as a good sign. Welcome to Unit 3. I want to talk to you about some coding stuff, but before we do that, I have talked to some of you before Unit 2 ended, and even in the last couple weeks or so, and I can tell that a lot of you are wondering why we've decided to inflict Java upon you. And it's a good question, and it's a fair question, and it deserves an answer. And so I really want to take a few minutes and explain why we're actually making this shift from Python to Java, and what you can expect as you are making that shift from Python to Java. The one thing that I think you already might have seen if you're going through the exercises is it's not going to be easy necessarily. I think there's a lot of analogies to learning human languages. Learning your first non-native language, right, is pretty tricky. But for you guys, that was Python, right? Python was your first computing language ever, probably for like the majority of you sitting in this room. And Java is now your second. So while it may not be easy, it's still going to be a bit easier than the first one is. And actually, I can let you know with certainty that it keeps getting easier and easier and easier after you learn these languages. So this is a good skill. This is a practical skill. Learning how to think in a different language is something that you are going to have to do if you are becoming a professional programmer. It's just a fact. And it gets to the point after a while where, if I want to learn a new language, I think of a project, I sit down and work on it for a week or two, and then I'm running. I'm up and running. That's a ways away from where we're at right now. I understand that. Java is going to feel different. It's going to feel weird. It's going to be a struggle. That's why we're here. That's why we're going to spend the next 7 weeks talking about it. But as Ryan was mentioning, there are certain economic benefits to choosing Java as well. It's the most popular programming language in the world. That is true. So that is another good reason to learn it. Python also very popular, of course. But Java is the most popular, and even more important, it is one of the most popular here in the St. Louis region. So perhaps the best economic reason of all to pick it up. And so that's what we're going to be doing the next next couple months. We're going to go until the end of June, like we just talked about. The structure of Unit 3 is going to actually pretty closely follow the structure of Unit 2. We're going to spend a week or two getting you transitioned over to Java. So we're actually going to relearn some of the quote-unquote basics that you picked up in Unit 1. You probably already noticed that from the exercises that we asked you to do before coming in today. We're going to cover all of the Unit 1 stuff in like a week or two, right? It seems really fast, but you guys have seen it before, and so the idea is that we'll be able to pick it up a little bit faster than you picked up Python in Unit 1. That's the hope, that's the goal. And then once that's done, we're going to make a project together, just like we did in Unit 2. It's a different project this time, but it feels very similar in a lot of ways. We're going to build a Java project that does some of the same things that we did with the flipped list project in Unit 2. And then you'll be building your own projects on the side as part of the assignments. And then as Ryan was just talking about, you'll build your own project again, your own personal project or group project perhaps when you go through Liftoff after this class is over. So the structure of the class is going to remain basically the same. The time's going to be structured basically the same. We'll have a review session / walkthrough / practice time for the first hour-ish of class, and then I will get out of the way, let you break up into your groups for the next chunk of class. And then if there is a studio, which today actually we do have a studio, we'll regroup at the end of class and go over the solution to wrap up the day. So before I hop into the new material, are there any questions about the upcoming few weeks in terms of expectations, structure, logistics, anything? Cool. All right, let's go ahead and get started. Let's talk about some Java. So let's start off with just some general Java questions. I'm going to try and relate stuff back to Python because that's what you guys know, right? That's what you're familiar with from the last 2 units. So let's just go ahead and start. Let's not beat around the bush. Let's just go ahead and start talking about some differences between these 2 languages. What are some syntax differences? So actually, let's back up a second. What is syntax? When I say syntax, what am I talking about? Syntax and grammar, actually, grammar is like the complement of syntax. The grammar is different too, and I want to talk about that.
The format.
Syntax is the format. Syntax, so in English, yeah, go ahead. Language is a very broad term. Yeah. The characters, the punctuation, right? Syntax is, in English, syntax is putting a period at the end of a sentence, right? Capitalizing the first letter. That's syntax, right? On a computer in Java, what's the Java equivalent of putting a period at the end of a sentence? Semicolons. Did Python make us do that? Sure didn't. No, it sure didn't. So there's already one difference. There's one difference already. What are some other syntax differences? Some other punctuation changes, some other formatting changes? Yeah. Curly brackets, yeah. So we've seen curly brackets before, but in a much different context. In Python, actually, do we even see them in Python so much? We saw them with what?
Our HTML.
We saw them in HTML, yeah. With the templates is the most recent time that we saw them, I believe, right? But in Java, they actually mean, or they're actually used for distinguishing a block of code, whereas in Python, what would we do? We would just do indentation instead. So here's something that you may or may not enjoy. Java doesn't care about your indentation. It does not give any thought to it at all. Does that mean that you should stop doing it? No, please continue to indent your code properly. You will thank yourself, your future self for that. When you have to go back and read that code that you wrote a couple weeks from now, you'll be very, very happy that you indented it. That visual cue is still very, very useful, even though the only thing that really matters in Java is the curly brackets. What else we got? Any other ones? Everything's a class, everything's an object, so that's more of, I would say, a more of a grammar difference than a syntax difference, but yes, that is true. Any other syntactical differences you can think of? We'll talk about the grammar differences as well, which grammar is thinking about the order that things appear in a particular program, or if you're thinking about English in a particular sentence, right? I can say a sentence that is syntactically correct but means nothing. It's just a bunch of gibberish, right? Same thing's true on the computer. Computers are a bit more nitpicky about that kind of stuff. Let's talk about one of the first and probably most noticeable grammatical differences between these two languages. Dynamic typing and static typing. What is that referring to? What's the difference between those two things? Yeah, in Java, I have to tell you what this variable is going to be. I have to declare the type of every single variable. We didn't have to do that in Python. We just made a variable and set it to a value. And whether you were, fully aware of it or not, in Python, if I decided that this integer needed to be a string later on in my code, Python didn't care. Python was just like, okay, this is a string now, whatever, right? Java, that's not going to fly anymore. Once I declare the type of a variable, that is the type of that variable for its entire life. I cannot switch types. The good news is, though, that I can create as many variables as I want. So if I really need to switch types of things, there's a way to do that. I just need to make a new variable with a new type to make that accommodation. So that's the biggest difference that most people see when they make this switch. It's actually pretty common to use static typing. Java is not the only static type language, not even close. Yeah, question?
You mentioned two different traits. It seems to me that the logically dependent, I'm trying to see if both characteristics of static typing. So one is that you have to declare the type up front. The other one is that the variable can't be assigned once you declare a certain type. You can't assign a value that has a different type.
Yeah, you're right. You're right. Those are two different things. In fact, I conflated them, and I shouldn't have. Thank you for calling me on that. You're absolutely right. The act of changing the type of a variable is what's known as weak typing, whereas if I declare a variable and it has to remain that type, that's actually known as strong typing, which is another difference between Python and Java, as a matter of fact. And often they do go hand in hand. It's very rare to see a static typed language that will let you change the types of the variables later on. So statically typed and strong typed are oftentimes going to be used together. I'm sure there are exceptions in the world. I'm not aware of any off the top of my head, but for our purposes, Java is both statically typed and strongly typed. Python then being the opposite of both of those things. Thank you. Any other questions on this particular topic while we're on the subject? What's the difference between a primitive type and a class type or a reference type? What's the difference? What's an example of a primitive type? Integer, char, yeah. There are others. Doubles, booleans, floats, strings? No, strings are not. Strings are a reference type. So what's the difference then? Right, so a reference, the name implies what it actually is. It's a pointer, it's a sign. We've talked about this in Python, but it's even more important to understand this for Java because of how Java is structured as a language. A reference is pointing at something, right? Whereas a primitive type usually just is that thing. I know that's an odd distinction to make between primitive types and reference types, but where this comes into play is the fact that in Java, as was already mentioned a few minutes ago, everything is an object except for primitive types. That's like the one exception to that rule. So you can think of a primitive type as the smallest possible way of representing a particular piece of data, right? If you had to take some big chunk of information and break it down and categorize it into the smallest possible chunks, right? What would you end up with? You'd end up with characters, you'd end up with ints, you'd end up with doubles, booleans, right? It's the smallest possible representable piece of information. Whereas reference types, object types, are going to take those primitive types, put a bunch of them together to make something a bit more meaningful, right? And we're going to create objects out of them. We're going to create classes out of them, just like we did in Python, actually. As a matter of fact, a lot of the object stuff, a lot of the class stuff that we did in Python is still relevant to Java. The biggest difference, again, is that in Java, everything is an object. Like, seriously, we're going to be dealing with objects all day, every day in Java. That's actually probably one of its biggest claims to fame, is the fact that it relies so heavily on objects. Java took this idea of an object and said, I'm going all in. That's my deal right there. I'm doing objects all day, every day. So that's something that we need to get used to. In Python, we can use objects, but we don't have to, right? If I don't want to use an object, I don't have to use an object. In Java, that's not true. The first thing that we asked you to do with that Hello World program is make a class, or it's inside of a class, right? It's part of an object. Everything in Java is part of an object. Doesn't matter what you're trying to do, no matter how simple, no matter how complicated. Any questions on that? That'll definitely be a point that comes up again and again and again as we go through Unit 3. Let's talk about arrays and lists. So lists being from Python, and then arrays being sort of similar, but not exactly the same as Python lists. Let's start with the differences. What are some differences between arrays and lists?
Arrays can only have one data type.
Arrays can only have one type of data. So this actually goes back to what we were kind of talking about before, right? With the static typing. Java being a lot less flexible in terms of what types things can or cannot be. When I declare an array, I have to tell you what the type of that array is, and then that's it. That's what the type of that array is. There are ways around that restriction that we'll see a little bit later when we get into some more object-oriented stuff, but in general, that is true. It has to be all one type. What are some other differences? I have to tell you what the size of the array is when I make it, and then can I change that size later? No, I can't. I cannot change the size of an array after I've created it. That's it. It's permanent. It is set in stone. We actually had a word for that. I know this is going way back to Unit 1. Immutable. Yeah, immutable. The size of that array is immutable. It's not going to change. It is what it is. I get to set it once when I create it, and then that's it. It's done. Whereas in Python, I could, extend my lists out. We used append quite frequently for that purpose when we were dealing with lists in Python. Any other differences you can think of between the two? What about similarities then? I'm sorry? Syntax, in a lot of ways, yes. So what kinds of things are we doing that's syntactically the same? Square brackets, so putting stuff into arrays, pulling stuff out of arrays looks very much like I'm putting stuff into a list or pulling stuff out of a list, right? Syntactically, that part looks very much the same. And all of your practice with lists from Python will come in handy when dealing with arrays, certainly. There's one other thing I think that's very important, similarity between the two as well. They're zero-based, and not only that, but there's an order, right? There's an order to things. So I put something into position 0, it's the first thing in the array, or the first thing in the list, right? So there is still some kind of an order maintained there, which is an important thing to be aware of when working with these particular data types. We're going to see more about this actually in just a little bit when we do a practice problem. This last one is a little tricky, but I think important and worth talking about. What's the difference between a static method and a function? So a static method comes from Java. Function, we've written many functions for. Python. What's the difference? Yeah. Mm-hmm.
That is like a standalone thing, it's not associated with an object where a method is. And what we think of it is the word static means that the method isn't just associated with a singular instance of that object,
Yeah.
but an entire class.
Yeah, that was a fantastic answer. Let me break that down. So the first thing you said was the true answer to this question. You could have stopped there and been fine, but you went above and beyond. The difference between a static method and a function, methods, the name method, your brain should think object. This is associated with a class, right? Doesn't matter what kind of a method it is. If I say the word method, it's associated with some kind of an object, which for Java makes sense because everything in Java is associated with a class. Everything. So what that really means then, like a function, as was described as just its own standalone unit of behavior, we can't do those in Java. Now that's maybe a little bit misleading. I don't know that we're going to get into any situations where we bend those rules, but for the most part, what we're doing, we're not going to write functions in Unit 3. That's not a thing that we are doing. We are writing static methods or non-static methods, and then you went on to describe the difference between those two things. We haven't gotten too deep down the object-oriented rabbit hole yet for Java, but we certainly will. And the difference between a static method and a non-static method, we actually saw this in Python as well, right? Is that a static method is associated with all of the instances of a class, or the class itself is a better way of thinking about it, whereas a non-static method is associated with a single instance of the class. But that's something that we're going to be talking about in the future, so if that concept is still a little fuzzy, we do have some prep work that'll help solidify that concept coming up in the next class or two. I do have a practice problem that I want to work on together as a group for a few minutes. I know I'm already a little bit over my usual time. Thanks, Ryan. But are there any questions before we get into a little bit of coding practice? Yeah, what's up?
What's the, if I don't, I'm sure you know, what's the basic history of Java?
Oh, that's a good question. So Java is still considered a relatively new language, although it's a little bit older than Python, I believe. Actually, I could be mistaken about that. Java came around in the 90s, so that's when it was first started. And one of its biggest claims to fame, besides the fact that it's all objects all day long, Java was one of the first truly cross-platform languages, right? It can run very easily. Other languages could run on any computer, but it took a lot of work. Whereas Java really wanted to make a true cross-platform language in the sense that I write one program and I give it to you and it works on your computer no matter what your computer is. And it works on your computer and it works on your computer. Other languages could run on every computer, but you'd have to make changes to the code in order to get it to function. Java, you don't have to do that. And the way that they get around that, or the way that they make that happen, is the Java virtual machine, which is actually a little, this is getting a little bit mind-bending here, but it's a little computer that it spawns inside of your computer. You can think of it as a little sandbox, right? And all Java programs run within that computer inside of your computer. That's how it pulls that off. For the 90s, that was like totally mind-blowing. Like everybody is just blown away that this was a thing that was technologically achievable. It really changed the trajectory of what was possible with programming languages, which is one of the reasons why it got so popular so fast and remains so popular to this day. These days, it's become, a little bit like, oh yeah, cool, JVM, whatever. There's other stuff going on in the world that, JVM's old news these days, but still very useful. Still does its job very, very well. So yeah, Java is still, I guess some other things about Java that may or may not be important to you is it's considered to be a relatively slowly evolving language. They're trying to make that not true anymore, but it used to be that Java would release a new version once every year, 6 months maybe, which is considered slow by computing standards. They're trying to change that these days, but it's always been considered a couple steps behind where the flashier, newer languages are in terms of the things that it can do or can't do. But if you're a big company that's got lots and lots of code written in a particular language, the fact that things aren't changing very fast is perfect for you. That's exactly what you want. So in that sense, there hasn't been a huge effort to change that too much. It's the first language that I ever learned, actually. So Python was your all first language. This was mine. I've been writing Java since 2006. So I've got quite a few years of Java under my belt, and I'm really looking forward to sharing it all with you, whether you love it or hate it. Not going to change my mind. I love it. So we're going to have a good time. Any other questions before we hop into some coding practice? All right, I've got a simple practice problem for you all. We'll do it together as a group. So I want to write a method, a static method. Maybe I should have made that explicit, but this will be a static method that takes in an array of integers and returns the sum of the first and the last value of the array. This is not the most practical method in the world, right? This is not going to land you a job interview anywhere. I can tell you that right now, but when you think about where we are in the context of this class, we're basically going back and starting from square one, learning a new language. So this is gonna, I think, probably show you a couple things that maybe weren't in the prep work for today. Give you a little bit of a clue as to how we can work with these kinds of things in Java. So I'm gonna switch over to IntelliJ, which is everybody's favorite new tool, right? No? Okay, well, it's actually, IntelliJ is a great tool, I promise you. We will show you all of the things that it can do. I mean, I don't know if any of you have gone through these menus and looked at all the things that are on here. There's a lot. I gotta be honest with you. I use about maybe, I don't know, half a dozen of them on a regular basis, and the other ones, I have no idea what they do. I'm not kidding. IntelliJ does a lot of stuff. It is a very big program that can do many things. Don't feel like you need to understand every single thing that it is doing, but I do want to show you some tips and tricks and shortcuts as we go through Unit 3. But for the sake of today's exercise, I just wanted to run through the basic process of making a new program. So starting from nothing, right? Let's make a new program, and let's just write a little bit of code and run it. Seems simple. You were asked to do this in the prep work, so hopefully that part should be a review, but let's go ahead and get started. First thing I'm gonna do is I need to make a class, and I need to decide where that class needs to go. So anytime I'm making a new Java program, that's step one, is making a new class. I have to decide what that class is gonna be. I have to decide where that class is gonna go. So I've got these things called packages here. This is the repository with the practice exercises in it, right? And so I'm just gonna pick this Java 4 Python package, or I'm not sure that it really matters where I put it, to be perfectly honest with you. Oh yeah, there's a whole lot of other stuff in here. Cats? Oh wow, okay, that's exciting. I don't know. It doesn't really matter to me which package, so I'll pick org.launchcode.java.demos, and I need to make a new class. And this is just a little bit of practice, so I'll call it practice. It's not the best name for a class. It really isn't, but it'll do. It'll get the job done. So the prompt, remember, I wanted to make a method. It takes in an array of integers and then returns the sum of the first value and the last value in that array, right? So I want to make a method now. How do I do that? What's the first thing I need to start typing in? I want to make a method. So the visibility of the method, yeah. For our purposes, for the purposes of this example, I don't think it really matters which one we pick. We can go ahead and pick public for now. We'll have a more in-depth conversation about when you should be choosing public or private in future classes when we talk about object-oriented stuff. For now, we'll just pick public and move on with our line. I mentioned earlier that I want this to be a static method, so that's going to come next. What's the next piece if I'm creating a method? What's the next thing that I need to define? The return. So what am I returning in this case? I'm passing in an array of ints. I'm taking the first value, the last value, I'm adding it together, and I'm returning it. So the return value will be an int. Yes. Okay, what comes next? The name. All right. Oh gosh, I can't think of a good name for this. First and last. First and last sum, whatever. That's a little bit of a mouthful, but it's accurate, I suppose, to a degree. What comes next? So if I'm passing something in, which the instructions I think explicitly tell us that we are, right? But in Python, I could just say, all right, this is, some value, right? And then move on with my day. In Java, though, that's not cool anymore, right? What am I missing? I need a type. So what's the type of this? It's an array of ints. So how do I say that? Int, and then square brackets tell me that it's not just one integer, but it's an array of integers. Do I know how big this array is? No. I have no idea how big this array is. It could be any length. I just know that it is an array of integers. Okay? And we'll stick some curly braces on there because that's how we distinguish blocks of code. And now we're ready to actually do some work. I actually think we could probably do this all in one line. It's not a particularly complicated task that we've been asked to do, but for the sake of practicing some other skills, let's break it up into some smaller chunks. What if I wanted to grab the first value out of the array and stick it in a variable? What would I need to start doing? Declare the variable. Yeah, declare the variable. So the type's going to be int, and then what comes next? The name, so I'll call it first, and then how do I grab the value, the first value out of the array? 0. Array bracket 0. This part here looks like Python. I could plug that into a Python program and it would run, right? But this part is what Java needs, and there's another thing that it's complaining about, the semicolon that Java needs. Right? All right, let's do another one where I get the last value out. This is a little bit trickier, but last equals what? array -1. So here's a difference that we didn't talk about. Java ain't gonna do this. Java does not want your negative values here. It's not gonna fly. You gotta think of a different way. In Python, there was a way for us to get an array to tell us how long it was, right? Java, we can do that too, but it looks different. So in Python, we did len. You can see it turned red right away. Java doesn't know what I'm talking about. So there's a different way to do it. And one of the most useful things that you can do in IntelliJ is that I can type the name of a variable called array, and then I can type dot. And then it spits out a whole list of things that are accessible to me through that variable. And actually you can see that it sort of guessed at what I wanted right up there at the top. The length of the array is in fact what I'm looking for. And so I can let IntelliJ help me out. That is a great habit to get into. Type the name of the variable, hit a dot, and see what's available to you from that list. Is this gonna work? I gotta take 1 off, good. We're almost done. What do I need to do? I need to add them together, so. Okay. Print. Return. I got to return. In fact, you could see, or maybe you saw that it's been mad at me this whole time because it says missing return statement. I told it that I was going to give it back an int. I said that this method is going to give you an int. That was a promise that I made when I wrote the method this way. And until I have a return statement with an integer associated with it, it's going to be like, where's that int you promised me? Come on, man. You told me it was going to happen. What if I decided that I didn't want to return an int? Or what if I didn't want to return anything? What would I do? Void. Void is the way that we tell a method that there's not going to be anything coming out of here, right? But in this case, we said we wanted to return an int. So I am obligated to do so, and this will work, right? That'll work okay. I could have made a third variable if I wanted to. Not necessary. In fact, I could have done this whole thing in one line if I wanted to, right? But I wanted to practice some other stuff along the way. So how do I use this? How do I test this out, make sure that it works? All Java programs, I gotta save it and compile it, but Java programs run a little bit differently than Python programs do, right? I need a main method. In a Python program, I can just run the file and it'll just start reading the lines from top to bottom, right? In Java, everything's an object. Everything's part of an object, so I have to tell Java exactly where I want to start, and the way that we do that in Java is with the main method. I have to have a main method. So the good news is that a main method is spelled out exactly the same way. It doesn't matter what program you're writing, how simple, how complex that program is. If you want to make a main method, they all start the same way. So you will memorize these words. These are the first words that I typed as a programmer, however many years ago that was. I don't want to think about it. Right? And I've typed them, I don't even know how many times since that day. Thousands, surely. Public, static, void, main, string, args. That has been forever burned into my memory. These will probably be my last words, you guys. On my way out. But we know what these parts mean too, right? Public, static. So public is the visibility, static means that it's a static method. Void, we just talked about that. It's not returning anything. This is the name. This is a parameter. So what's the type of the parameter? It's an array of strings. I know it's an array of strings, so I see the square brackets here. And the name of this is args, which is short for arguments. This is actually sort of a relic from olden times when we used to run everything from the command line. I could provide arguments on the command line to a program. This is where they would end up in my code. We don't necessarily do that as often anymore. We still do sometimes, but it's not as common as it used to be. And so a lot of times we just end up ignoring this poor variable, but it still tags along for the ride. Has to be there in every single main method that we write. Okay, And so now what we want to do is we want to run some tests on this method. And what that means is I'm going to have to create an array or two, right? In fact, I want to do it twice because there's two different ways to create an array, right? So I want to take a look at both ways that we can do to create these arrays and test out our method. So one way to create an array, let's create variables for these. So first thing when I create a variable is the type, which is an array of integers. Then I give it a name. I'll call it A1. So one way that I can create an array is how? What's one way that I can use to create this array? Yeah, go ahead.
Well, I think you can like do it literally by putting giving it a list.
I can give it some values. If I know what the values are that I want to be in this array, I can say that right now. What do I need to include to make that happen? Curly braces. So then I can just put a list of values in here. Doesn't matter, right? So that's one way that I can create an array. What's another way that I can create an array? Let's make another array variable. What's another way, second way? I know this was in the prep work. I can create an empty one, right? And then tell it how many things I expect, tell it what the size of the array should be. What's the next word that I'm going to type if I want to do it that way? New, that's right. That's exactly right. And then what comes next? New int, brackets, but we're not quite done. This is where I tell you what size I want it to be inside of the brackets there. So the difference between doing it this way is that this array is filled with these values. If I know what I want the values to be, this is a good way of doing it. If I'm not sure what values I want to go in this array, or I'm going to figure it out later, right? Then this second way is the appropriate way to do it. This array, when I say it's empty, that's a little bit misleading. Does anybody know what's actually in that array? It's all zeros. Yeah, it's all zeros all the time until I decide to change it. So let's real quick just change some values in this array. How would I change the first value to be something different? What would I say? I need to use an index, that's right. A2 at position 0 equals 7. Why didn't I have to do this? Why didn't I have to do that? I already told it what the type of A2 was, right? It's going to remember that. I don't have to tell it that it's an integer array every single time. It will remember. It will remember that fact. So that will change the first value to a 7, and then I can change the next value to be 19, right? And the last thing that I want to do now is call this method twice, once for both of my arrays, and then print out the results. I should be able to see that the first result should be 7, and the second result should be 26, if everything works the way that we expect it to. So how do I print something out? System.out. Oh, here's a whole bunch of options, right? Print ln. What's the difference between print and print ln? Does anybody know? Print ln moves you to the next line. It's like you're using a typewriter, right? Print ln moves you down to the next line after you're done, whereas print is going to keep you on the same line as you left off at. That's the biggest difference. This is kind of a mouthful, right? In Python, we just say print, done. This is kind of a mouthful. This is an object. Well, it's a class, rather. This is an object, right? So here's already, we're using objects as part of our Java program. Java is going to have a lot of objects all over the place. And this is one example of that. And so I just want to, I skipped a step. Sorry. What step did I skip? Before I can print out anything, I need to, I'm sorry? I didn't call the method. Yeah, I skipped a step. I got to call the method. First and last sum, give it an array. Will this work?
variable?
I should stick it in a variable. I should make a variable, right? Int result equals. This int has to match the return type because I'm taking the value from this, sticking in this variable, right? Results. Or if I wanted to, I could have taken a little bit of a shortcut. We can do that with the second one. I could just call it directly inside like this, right? Okay, now is the moment of truth. Now we need to see if it actually works. I saw several questions about this on Slack about running programs. It's not exactly intuitive. There are a couple ways you can run your code on IntelliJ. One is you'll notice that when I wrote this main method, this green triangle showed up right next to it. So if you write a main method in IntelliJ, it will assume that you're eventually going to want to run that main method, which is true, and it will put this green triangle next to it, so I can click that to run it. Or alternatively, I can find the file that I want to run over here on the list, and I can right-click that file and go down to Run, Practice.main inside of this menu. They both going to do the exact same thing. It doesn't really matter which one you use. We'll go ahead and do it that way, and hopefully I'll see the values come out that I'm expecting, which again should be 7 and 26. It's taking a minute to compile. There we go. That was the longest 7 and 26 computation I've ever seen in my life, but it did eventually get there. Yep. What questions do you have about this? Yeah, what's up?
So can you import system.out in order to just use a print line?
Yeah, you absolutely can. So if I wanted to, if I'm getting tired of typing this every single time, I can actually do something similar to what Java would do and import it, or I'm sorry, similar to what Python might do and import it, and then use it directly in my code. Yes, you could do that. The syntax for doing that actually escapes me right now. I know I've seen it, but I haven't done it recently. I get so used to IntelliJ, I don't know, I can't remember 5 minutes ago, sorry, but you know, I start to do stuff like this where I type out the first few letters and, oh, IntelliJ knows what I'm talking about, tab, dot, oh, there's out tab, right, dot, oh, there's print line tab, and I'm not even typing the thing anyway, I'm just letting IntelliJ. I've gotten into those habits, which I know are terrible if you're trying to follow along with me. So if I start doing stuff like that in class, please holler at me to slow down. I want to take things at a pace that is useful for you all. This is not a race. So any other questions? Yeah, what's up?
When you create a class, can you create multiple methods?
You can, absolutely.
Leverage those methods, you have to put them in your main method, right?
Well, so the first question was, can you put multiple methods in a class? The answer is yes. In fact, I've got multiple methods here. I've got 2, but I can have as many as I want. It's like Python objects in that sense. I can create as many methods in my Python objects as I need to get the job done. Now, a main method is just an entry point into a program. It's a starting point, right? So not all classes are going to have one. It's not necessary for all classes to have a main method. If I've got a very big program with 10 classes in it, right, there's still just going to be one entry point, one place where that program starts, even though I might have 10 different classes. So for the simple examples that we're doing this week and into next week, you know, we'll probably see a main method in most of the classes that we write. But as we start writing bigger and more complex programs, we'll stop seeing that happen so often. Great question. Any other questions? Yeah, what's up?
That drop-down box in the top right where it says practice. I tried whatever you just did, a little program on my own. I did that, and then I did the green button to run the hello program. That's go score.
Right.
That's what to do with that, right?
So yeah, so if you've ever hit this button up here, if you're trying to run a program that you've already run before, this button is great. If you're trying to run a program that you have not run before, this button's not going to help you. This button is useful. This drop-down is actually a list of all the programs that I've run recently, and you can can see the only one I've run recently is the one that we just did. If I ever wanted to run one of these other ones, IntelliJ has not compiled that yet, has not turned it into binary, turned it into ones and zeros yet. And so I need to do that a little bit differently, going through the menu to do that a little differently. But once I have done that, it will show up here, and then I can select it and run it this way. Great question. Any other questions? All right. You guys have a studio today. Some of the TAs have fluctuated and or disappeared, unfortunately, moved on to other things for various reasons. So I think we might be a little short-handed today, but there are still plenty of people around to help you out. Your priority today, actually, if you haven't done so already, or if you tried and got stuck somewhere, is to get IntelliJ up and running so that you can run Java programs. I know people were struggling with that. If you need help with that, please use today for that purpose. And once you are satisfied that you've got IntelliJ up and running, then there is a studio for you today to take a look at. We'll do a review on that in about an hour. And then, yeah, like I said, let us know what help you need.